Hey guys, this video is about angles formed by parallel lines when parallel lines are cut by a transversal. So it's going to look very familiar to all the vocab that we've already learned. The only difference now is that the lines are parallel. So that would be indicated by this symbol or by the arrows on the two lines that are not the transversal. And so what we're going to be investigating is what happens to our angle pair relationships when the lines are parallel versus if they're not parallel. For the first part of this investigation, you want to just go ahead and measure all of the angles on this worksheet using a protractor. So hopefully you were able to get this done in class. If you do not have a protractor, it is not acceptable to leave this page blank. Go to Google, type in protractor, and a paper protractor will show up. You can just print it and use that. In case you don't believe me, here's a bunch of examples. I just typed protractor into Google. Any one of these will be great. You just click on this, hit print. It works the same way as the protractors that we have in class. This chart is going to be like your saving grace through this unit. So take a second to go ahead and fill in the numbered angles. You want to make sure that you get them exactly the same orientation that my numbers are. Otherwise, your whole chart's going to be messed up. So the first vocab word that we're going to look at is alternate interior angles, which we already know would be like example angles 4 and 5 or angles 3 and 6. And I spoke about in class a little bit how you can look for the letter Z. And what you should have noticed from the investigation on the front of this worksheet is that if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. That's called the alternate interior angles theorem. You don't really need to memorize this, but you do need to know how to write the if-then statement. And the important thing is that you always start with if two parallel lines are cut by a transversal, or you can simply say if lines are parallel, if lines parallel, comma, then all of these relationships happen. The second relationship is the alternate exterior. So just to remind you, that would be like angles 1 and 8 or 2 and 7. There's not really a hint for this one, so you can kind of leave that one blank or cross it out. You just have to know the exterior, alternate exterior. What you should have noticed from the investigation is that when the lines are parallel, then exterior angles are congruent. So again, all of these relationships only happen when the lines are parallel. Corresponding angles, examples would be like angles 1 and 5, 3 and 7, 2 and 6, 4 and 8. A hint for corresponding angles is to look for the letter F, and the easiest way to see that on this example is if you connected angles 4 and 8, like you can pretty clearly see the F. If the lines are parallel, then corresponding angles are congruent. And that is a postulate. A postulate is different from a theorem because it's just accepted without proof. A postulate is used to prove that other theorems are true. So that's just the only difference. Consecutive interior angles, to remind you, examples would be like 3 and 5, 4 and 6. And we also did talk about in class how you can look for the letter C. Just don't get it confused with corresponding, because these are on the interior, whereas corresponding angles, one's on the interior, one's on the exterior. If the lines are parallel, then consecutive interior angles are supplementary, which means that they add up to be 180 degrees. So they are not congruent like the previous three angle relationships we just talked about. A linear pair we already know a lot about, but it's good to just put in this chart that linear pairs do exist in parallel lines cut by a transversal. They're still supplementary, which means that they add to 180 degrees. Some examples would be angles 1 and 2, 3 and 4, 5 and 6, 7 and 8. Also, angles 2 and 4. I'll add that over here, angle 2 and angle 4. or angle 6 and angle 7. Those are also examples of linear pairs. Oh no, not 6 and 7, 6 and 8. Whoops. So whenever you're doing one of these examples where you have two parallel lines cut by a transversal, it's really important to just keep in mind what you know about linear pairs because it can help you find other angle relationships. Some hints to look for would be the letter T. So for example, if I created a letter T here, 3 and 4 would be a linear pair. Or the letter Y might also help you out, like for 5 and 7, you could look at the angle Y. The last vocab word we talked about is vertical angles. There's a ton of examples in these problems as well. We've talked about how to look for the letter X, and vertical angles are always congruent, even if lines are not parallel. So I'd add that in. Whoops, even if lines are not parallel, vertical angles are always congruent. At the bottom of your page is just a reminder of some of the theorems that we've talked about for perpendicular lines and parallel lines. I threw those on here because I think it will be helpful for you guys as you go through this unit to just have everything into one organizational chart. That way you don't have to keep flipping back to your notebook. So if two lines intersect to form a linear pair of congruent angles, the lines are perpendicular. If two adjacent angles are complementary, if two adjacent angles are perpendicular, then their angles are complementary. You can see from the right angle sign anyways. Two perpendicular lines form four right angles. And then the last couple of ones, the parallel postulate, if there is a line and a point not on the line, then there is exactly, I should say one line through the point parallel to the given line. So to give you an example, if I have a line and a point not on the line, so let's say it's over here, point A, then there is exactly one line through that point that will be parallel to the given line. So no matter where I draw this line, there's only one way that I can do it so that it would be parallel to this given line. And the reason for that is because if I change the orientation of this line by just 1 degree or half a degree or any amount at all, it will eventually cross with this other line. So one way you can think about that is if those two angles are 90 degrees, there's only one way to create that. And so if I had any other angle besides 90 right here, then these lines would not be parallel. Which kind of leads into postulate 14, which, by the way, you don't need to memorize the numbers for these. You just want to understand what the postulates are saying so that you can answer a question or explain or support a claim. So the perpendicular postulate says if there's a line and a point not on the line, so I'll draw the same diagram, then there's exactly one line through the point perpendicular to the given point. So if I were to try and draw a line through this point so that it crosses this other line at a 90-degree angle, there's only one way to do that. It kind of relates to this thought back here, because if I wanted to find the distance between these lines, if they were parallel, then the distance would be the same no matter where you are on these lines. Like this distance would be this distance, would be the same as that distance and that distance. And the way that you measure distance is always with a 90-degree angle. Hopefully this chart will be helpful to you guys as we go through the unit. Keep this in a safe place. You do not need to, tape this into your notebook like I've done. You want to keep it handy, but if it's helpful, you can paper clip it or staple it or something, but make sure you're able to see both sides of this chart. Okay, here's the first example. Solve for all missing angle measures. So the first thing that I noticed right away is that lines A and B have the little arrows on them, which means that A is parallel to B. If those two lines are parallel, then I know that all of the angle relationships we just put into that chart will apply. So I could start off down here, 62 degrees. Well, I know that this one's going to also be 62 degrees because they're vertical angles. I know that if this is 62 degrees and the lines are parallel, then corresponding angles will be congruent. So that means this angle will be 62 degrees as well. And then I have another pair of vertical angles here, or I can figure out this angle by going back to if my lines are parallel, then corresponding angles are congruent. So either way you think about it, this angle is also 62 degrees. So now I have a couple different ways that I could think about my remaining missing angles. So I already know about linear pairs. I know that linear pairs add up to be 180 degrees. So I can find this missing angle. Come on. Let's try another one. I can find this missing angle by subtracting 180 minus 62, which would give me 118 degrees. And now the whole process kind of starts all over again. So I know that this has to be 118 degrees because these are vertical angles. I know that if this is 118 degrees, this angle has to be 118 degrees because if my lines are parallel, then corresponding angles are congruent. I can also think about it this way. Look for the C, so consecutive interior angles. I know that consecutive interior angles have to be supplementary. So if this is 62 degrees, this must be 118 degrees as well. So you can start to see that really in a set of parallel lines cut by a transversal, there's only two different angle measures. All right, here's an example that involves algebra. So example 2 says find the value of x and y. So the first thing that I want to look for is any angle that does not have a variable. So that would be this 100-degree angle. And see if you can work off of that angle first because you already know what it is. So I noticed that my variable y is over here. It's right next to the 100 degrees. It's adjacent. It also forms a linear pair with that 100-degree angle. So the first thing, just like all our other questions, find your relationship. Identify the relationship. You don't need to write it out like this every time. I'm just doing this as a reminder. So my relationship is a linear pair. Then set up your equation. So we know that linear pairs add up to 180 degrees. So 2y plus 100 equals 180. And now I can solve for y, plug it into here, and figure out what this angle measure would be. So minus 100, 2y equals 80, y must be 40. So that means this angle is 80 degrees. Okay, now a couple of different ways that you can solve for x. Well, I noticed that there's a set of alternate exterior angles, but I also noticed I could use corresponding angles as well. So right now I've figured out that this is 80 degrees, which means that this green angle I've marked over here, the 80-degree angle, and 8x are alternate exterior angles. So if the lines are parallel, which they are, we know that alternate exterior angles are congruent. That's one way you could solve this problem. Some of you might be looking at this like, well, if this is 80 degrees, that means that this must be 80 degrees because vertical angles are congruent, or linear pairs add to 180. So the 8x and this 80-degree angle would be corresponding. And again, if the lines are parallel, corresponding angles are congruent. There are so many ways you can think about these problems, which is why it's really important when you're doing group work that you just share your thoughts, because you might see it differently than your partner, or your partner might have an idea that might help you see it better. So I'm going to use these two angles, the 8x and my 80-degree angle that I just solved for, because you don't even need this one, but it's there. I mean, you can use it if you would prefer. But I know that these two angles are equal because they're alternate exterior and my lines are parallel. So 80 equals 8x, divide both sides by 8. 10 must equal the value for x. So I found x and I found y. Again, you can always, plug this back in to check your answer to see if it makes sense. We're going to be doing a bunch of problems like this, and keep in mind there are many, many ways that you can think about these questions. So just be respectful when you're working with others. Listen to what they have to say. If you disagree, just wait for them to finish their thought, and then you can provide your insight as well.